Hi guys and welcome back to the channel. Not so long time ago I got my hands on this and well, what is this? Well, first let's taking it out from the box. It is a mini fridge. To be more specific, a Coca-Cola mini fridge. But sadly it doesn't work from what I know. As from where I got it, most of the products didn't work. So here is that. Now the fridge looks quite nice despite that it's not working. So in this video I'll be attempting to try to fix it, instead of just trash it away or scavenging for parts, because to be honest it doesn't contain too much. But anyway, I am diverging now. If we open the front door, here we got the power supply, the PSU, which is rated 12 volts and 4 amperes, which is around 50 watts PSU, which is not much, but still the fridge is small, so what I can expect. So let's plug in the power supply and then flip the fridge and insert the power cord, which is quite awkward shape to be honest. But this I think is done to prevent accidental reversing the connection. With the plug connected, let's flip the switch and it does nothing on cold mode. Also on warm mode as well it does nothing. Well, let's check with the DVM, setting it firstly on DC and check if the power supply is outputting some voltage. And you can see it's outputting about 12.40, which means that the PSU is working. Also I got a small LED to see if the power supply it's working properly. So we can see that the power supply is working wonderful. I know it's a small load, this LED is around 5 watts instead of 40 watts this mini fridge is using. So after tackling the first issue, blaming the PSU is not working, let's move up to the stage 2, which will be to dismantle the fridge further by firstly removing the 6 screws from the rear cover. And after doing so, well, we got a dusty boy. Anyway, after a quick clean with the brush, I start having a closer look at the PCB and measuring with the help of the DVM few points. Firstly was the power rail to check if the connector is good, and as you can see we are getting around 12 volts, which means that the connector is good. Let's move a bit further and check more points on the PCB. So let's dig a bit further by firstly peeling the rear label, which is hiding 2 screws which have to be removed in order to get a closer look at the PCB. Also we can see on the PCB we got 2 diodes, but they are just some standard 4007 silicon diodes. Let's test them anyway to make sure they are good, but I don't think if one of them is bad it will make this fridge not working at all. So let's check the first diode. The first one on forward is showing around 0.5, meaning half a volt drop, and on forward is showing around 0.8. This doesn't mean that the silicon diode is bad, it's just something else connected to it, in parallel or in series usually. Let's move to the second one. The second one as well is showing about 0.5 voltage drop when it's in forward, and when it's in rivet forward it's around 0.8. The same behavior. Let's check the peltier module resistance, maybe that's the culprit of this mini fridge. So let's place the DVM resistance and then see on the board where the 2 peltier wires are connected and test them. And as you can see, normally the peltier module has 50 to 50 ohms resistance, so it's a low resistance. But let's check it a bit better by seeing if the resistance is changing when a change in temperature is occurring. I will simulate that by using my hot air station, and as you can see on the DVM, the resistance starts to go up. This shows that the peltier module is good. Okay, let's move to the next component, which is beside it, which is that one I have firstly to measure. That one is showing to be around 6 million, which is a lot. Anyway, let's dig a bit further by removing the heatsink from the fridge, and after the 2 screws have been removed, the peltier module is exposed. And also I noticed that we got a thermic switch. Normally those they are used in microwaves, but I think they can be used as a safety mechanism in a mini fridge to cut the power on the peltier reaching high temperature. And let's test that one. Usually this one have to be normally closed, because there are few types out there, normally open and normally closed, but this one should be normally closed, but when the temperature is approaching the rating specification it will be triggering and opening the circuit. But this one doesn't work at all, it seems to be completely open. So let's check something on the board by using a flathead screwdriver and jam the 2 thermistor wire, and if doing so, well, it has come to life. Nice. So we know that is the culprit. Also, by touching the peltier, I am feeling that it's getting hot on one side and cold to the other side. Also, we see we got a nice peltier module, 12704. It's rated at 12 volts and around 4 amps, which is the same as the power supply to be honest. So after finding the culprit, I know what I have to do. So I went in my stash because I got some of them laying around and checked to see if I got one which match the specification of the one inside the fridge, which by the way is rated at 250, 10 amps and around 85 degrees, which this happens to be a proper microwave temperature switch. But anyway, let's find a suitable replacement, but let's firstly show you the small test using one randomly. This one seems to be normally open, and if I simulate a change in temperature using my hot air station, I can see and as well hear the DBM closing the contact inside of it. So after finding a suitable replacement, I solder it and also reapply some new thermal paste and start to reinstall the mini fridge back. And here we have it. The fridge is fully assembled, looking quite nice. Well, I hope you find this video interesting, but now I have to say goodbye. I hope I will see you all in my next video. Until then, I want to thank you all for all the support, and I shall see you all the next one. Till then, have a nice day and thank you very much for watching. See ya!